Hi, wonderful evening to each one of you. Today, we are going to explore some secrets, valuable secrets related to the concept of average velocity, um, which we usually deal from class 8th onwards, 8th, ninth. But uh, we need to explore various situations related to average velocity in class 11th. So, most of the people, according to my experience, most of the students, they keep on mugging up the equation to find average velocity in various situations. I wanted each one of you to understand with clarity the logic and um, the meaningful way of calculating average velocity. So let me share my screen without wasting your time. So let us do with that. Okay. Yes. Now we are considering first the case of a uniformly accelerating object. What is the average velocity of a uniformly accelerating object? We will be able to find out average velocity of a uniformly accelerating object easily with the equation v plus u by 2, or initial velocity or final velocity plus initial velocity by 2. The average value of initial and final velocities will give you the average velocity. Most of the students, as I mentioned earlier, they keep on mugging up this particular equation. But I want each one of you to know how this equation is valid, or what is the logic behind using this particular equation in the case of an object which is under uniform acceleration. Now, we know that, or I would like you to remember very important, very critical information related to this. In all the cases, the average velocity can be obtained by taking the total displacement and the ratio between total displacement and total time taken. So, total displacement by total time interval will give you the average velocity in each and every situation. Only one equation you need to internalize, you need to understand. In order to find the average velocity, the only equation you need to recollect or remember is total displacement divided by total time taken. Now, in the case of a uniformly accelerating object, what about the total displacement? We know that particular equation with clarity. It is nothing but S is equal to ut plus half a t square. This is the equation we know from class 8th or ninth onwards. What about the displacement? What is this equation uh, giving us? This equation gives us the total displacement of an object which is starting with with an initial velocity u and with a constant acceleration a and in a time interval of t seconds. Okay, so this equation gives you the total displacement of an object in t seconds whose initial velocity is u and having a constant acceleration a. So I wanted to iterate that. That is why I repeated the statement once again. So here, what about the total displacement? It is nothing but S. S is the total displacement. How much is the time taken? It is nothing but t. So by simply taking the ratio between total displacement and total time taken, you will be getting the average velocity in this particular case. Now, let me substitute the value of S in this particular equation. Ut plus half at square divided by t. Now, t gets cancelled from both the terms. So the final result will become u plus at by 2. Okay, this is the final result. Now we are taking the LCM on the RHS. That is, you will be getting 2u plus at by 4 divided by 2. That is what we are getting from this particular equation. Now, I can write this equation to be u plus at. That is, I split 2u into u plus u plus at divided by 2. Now you think about it. What is u plus at? It is the final velocity in the case of a uniformly accelerating object. So we can substitute u plus at with v. And with that, we get the average velocity to be u plus v by 2. The same equation we have written above. So this is the logic behind getting this particular equation. The average of initial and final velocities will give the whole average velocity for any object which is under uniform acceleration. So this is case 1. I wanted each one of you to have better clarity on finding average velocity by demonstrating one more situation. Here the situation is somewhat different. Listen me. Here, consider an object starting from this particular point O. Okay. Now, here the situation is the object is covering equal displacements but with different velocities. First displacement S with velocity v1. Next, same displacement it covered with a different velocity. Okay. So this is the pattern it is following. Okay. And finally, it covers the last S displacement, that is nth displacement, which is again equal to S with a velocity Vn. So the situation is the object is covering equal displacements, but with different velocities in each case. That is the situation. And the object has covered n such equal displacements with n different velocities. That is the situation given here. So here also we need to remember the same general equation to find out the average velocity. What is that? It is nothing but the total displacement by total time taken. Now what about the total displacement here? Simply we can say that n times S will be the total displacement. Now we wanted to find out the total time taken. Well, how about the total time taken in this particular case? See, we know that the equation for velocity is equal to displacement by time taken. So here, for the first interval, we have the displacement to be S, but velocity to be v1. That we can substitute here, v1 is equal to S by t1. So that t1 equals S by v1. So that will be the time taken by the object to cover the first S displacement with velocity v1. By following the same pattern, we get the time taken by the object to cover the second displacement to be t2, which equals S by v2. And the same is true for next intervals as well. t3 will be equal to S by v3. And finally, the nth interval, the time taken to cover the nth interval will be equal to Tn, which is given by S by Vn. So now I wanted to add all these time intervals, T1 plus T2 plus, that means, yeah, I will write it down, T1 plus T2 plus, etc. up to Tn. So the total time taken should be calculated, and we need to divide the total displacement by that total time taken. Now, the total displacement, as we already know, it is ns. Then what about the total time taken? It is S by V1 plus S by V2 plus etc. up to S by Vn. Now, from the denominator part, we can take the common factor outside. So ns in the numerator. From the denominator, we can get that common factor out of that. Then 1 by V1 plus 1 by V2 plus etc. up to 1 by Vn. Now, we have the opportunity here to cancel out the S from both numerator and the denominator. Now, the equation for finding the average velocity is almost with us, but we can make some small tweaks to get a standardized format. Okay, I'm taking this V average to this side and the entire denominator on RHS to the LHS. So the equation will become N by V average is equal to 1 by V1 plus 1 by V2 plus etc. up to 1 by Vn. So this is the equation to find out the average velocity. Okay, now let us discuss two special cases related to this. That means, see, let us consider the object covering two equal displacements with two different velocities. S, S, with velocities, first half covered with velocity V1, second half covered with velocity V2. In this case, the total intervals, here n is the total number of intervals. Here n equals 2. So 2 by V average becomes 1 by V1 plus 1 by V2 in this particular case. Now, taking or simplifying the RHS will give us V1 plus V2 divided by V1, V2. On LHS, we are having 2 by V average. Now, by rearranging this equation, we will get the equation for finding average velocity to be 2 V1, V2 divided by V1 plus V2. Sorry, V1 plus V2. I have written V3 by mistake. Okay, V1 plus V2. This is the equation if the object is covering two equal displacements with two different velocities. And I have something for you to work and find out, which is if I'm going to extend the same situation for three equal intervals, the equation will be, in that particular case, V average will be equal to 3 V1, V2, V3 divided by V1, V2 plus V2, V3 plus V1, V3. Now, I want each one of you to experiment with this particular equation by following the general equation, that is n by V average is equal to 1 by V1 plus 1 by V2 plus 1 by V3. Will you do that? So if you practice this, you will get better insight related to this one. Now again, I wanted you to take through another example related to this itself. Now here, you see the situation. Again, this particular object is starting from the point O, but the case is different here. Here there are, here the situation is, the object is covering or traveling for t seconds with a velocity v1. Then for the next t seconds, it travels with a velocity v2. Then again, for the next t seconds, it travels with velocity v3. So continuously, its velocity keep on changing, and this process continues for n t seconds, n equal time intervals. That is the situation here. Now, with this particular situation, we wanted to find out the average velocity. Then again, I want each one of you to follow the single or one and only equation which will help you to find out the average velocity, which is total displacement by total time taken. Now, we shall consider the displacement of the object in various time intervals. You think about it. For the first time interval, we shall again depend on the equation, general equation, to find out velocity v is equal to s by t. Now, what about s1? The displacement during the first t seconds will be equal to v1t. Then what about in the next t seconds? S2 is equal to v2t, and so on. Finally, the displacement during the nth t second will become vnt. Okay, so what about the total displacement in all these cases? S1 plus S2 plus etc. up to Sn. That will give the total displacement divided by total time taken. How much it is? See, here we shall remember that each time interval is equal. So t. How much t or how many t? N times t. So the total time taken is nt. Now we can substitute for S1, S2, S3, etc. So how much it is? V1t plus V2t plus etc. up to Vnt whole divided by n times t. Now, see, in the numerator part, t is the common factor. So we can take it out to be V1 plus V2 plus etc. up to Vn into t. Common factor is taken out divided by nt. Now, what we are getting? We are having the freedom here, cancel the t, which is appearing both on the numerator and the denominator. Final equation comes to be, final equation to find out the average velocity in this particular case is found to be v1 plus v2 plus v3 plus etc. up to vn. Sorry, I was supposed to put some dots here. V3 plus etc. up to Vn divided by, sorry, n. Yeah. So here the average is absolute average. See, you need not bother about anything. In this particular case, if the object is covering equal or traveling for equal time intervals, but with differing velocities, in that case, you get all such velocities followed by the object and take the average. You will be getting average velocity. Okay. So I want each one of you to practice all these steps at least twice or thrice, internalize the concept. After that, you keep practicing with numericals. This will help you to strengthen the concept, as well as it will help you to internalize the situation. And you will never forget this in your life. Okay, if you are learning the concept and numericals in a balanced manner. And my suggestion to each one of you, not to rely on rote memorization techniques. As per various studies conducted by premier or prestigious institutions in India like IITs, NITs, AIMS, JIPMER, and ICERs, various ICERs, it is found that those students who are entering these kind of premier institutions by cracking reputed or premier national entrance exams with very high ranks, they are not having the conceptual clarity, application, real life application skills related to a subject, physics, which is considered to be one of the most beautiful subjects you can learn on this planet. So if you want to know more about learning physics meaningfully, I would like you to attend a 2-hour free webinar conducted by me, which is called as Physics Made Easy. Okay, You can register for the free webinar, 2-hour free webinar, by clicking the link given in the description. It is a 2-hour webinar. I strongly recommend each one of you to attend this particular webinar along with the parent, or let me put it in this way, both student and parent attend the webinar together so that you both will get better clarity, better insights, and I will guide you some unique strategies to follow to become one among the top 2% in the whole country. Not by mugging up the subject, or neither by mugging up the subject, nor by following some kind of rote memorization techniques. So click on the link and register for my webinar. If you find value in this particular video, yeah, let me come back. Okay, let me stop sharing this. If you find value in this particular video, please like this video and please share your comments below this particular video. So see you next day at the same time. I'm on a challenge to attend here live every day. Monday to Saturdays, I will be appearing here at 6:30 p.m. and on Sundays, I will be live in this platform at 10:30 a.m. So thank you for being here. Thank you once again.